Yo, 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 this is Mr. O. Yo, 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 this is Mr. O. And today we're going to learn about evaluating logarithmic expression. Let's go ahead now. Before we try to learn about the evaluating logarithmic expression, let's remember the basic things. 2 to the 0 is equal to 1. Anything that raises 0 is equal to 1. 2 to the 1 is 1. No, my bad. 2 to the 1 is 2. 2 squared, or 2 times 2 is 4. 2 to the third power is 8 because 2 times 2 times 2 is 8. 2 to the fourth is 16. And 2 to the fifth power is 32. 3 to negative 1. We remember before one of the properties of loss of exponent that if you have a negative exponent, that will change its position. On this case, 3 to the negative 1 will go down, so the answer is 1/3. 3 to the 0, anything raised to 0 is equal to 1. 3 to the 1 is 3. 3 squared, 3 times 3 is 9. 3 times 3 times 3, 3 to the third is 27. And for the fourth time is going to be 81. 4 to negative 2. This is same thing as 4 negative 2. This will go down as 1 over 4 squared. But 4 squared is 16, so the answer here is 1 over 16. 4 to negative 1, like the previous one, this will be 1 over 4, so it's going to be 1/4. If you notice, the negative exponent will bring down the base down, and then you simplify from there. 4 to 0 is 1, 4 to the 1 is 4, 4 squared is 16, and 4 to the third is 64. These are some basic evaluating exponential expression. Now, let's go to the properties. If you notice that log of 4 to the base of 4, the base here is the same as the log number, the answer there is 1. Why is it 1? Because 4 to the 1 is equal to 4. Log of 5 to the base of 5. And again, the base and the log number are the same, so the answer is 1. What if we have log of 1 to the base of 2? The logarithmic number here is 1, and the answer there is going to be 0. Why is it 0? Because 2 to the 0 is equal to 1. What is that exponent to the base of 2 that will give us 1? It's going to be 0. Same thing with this. What is the mystery exponent of the 5 to get a 1? It's going to be 0. So that's the answer 0 there. Next, log of 1/3 to the base of 3. So 3 was the mystery exponent of the 3 that will make it 1/3. Remember that if it's negative 1, that base will go down. It will be equal to 1/3. So the answer here is negative 1. Log of 1/4 to the base 4 is same thing. 1/4. No, I'm wrong. Here, base of 4 was a mystery number exponent there. It's going to be negative 1. That will create it as a 1/4. So the answer is negative 1. Okay, so let's move on now in evaluating logarithmic expression. First way, there are two ways of doing this one. The first way that I would like to share to my kids is that you need to be able to answer a question, what must be the exponent of the base to get the log number? On this case here, the base is 2. What must be the exponent of 2 to get an 8? Remember, 2 to the 1 is 1, 2 to the second power is 2, 2 to the third power is 8. So the answer there is 3. So it's 3 equals 8. So the answer here is 3. What is the mystery exponent of 3 that will give me a 27 here? The answer is 3, because 3 times 3 times 3 is 27. So this one here, log of 1/8 with a base of 2. What will be the mystery exponent there that will make it 1/8? And we know that 8 is same thing as 1 2 to the third power. And if we bring this up there, it will become now 2 to the negative 3. So the answer is negative 3 there. Another way of doing this one is writing it out in an exponential form and solve it using exponential equation. Here, what we do is we set it equal to x, set it equal to x, set it equal to x. You will convert this one into exponential form, which is 4 to the x is equal to 16. Now we have to write them down wherein their base can be the same. 4 to the x, we write 16 as 4 squared. Since their bases are the same now, this can be cancelled, so therefore x equal to 2. Same thing with this. 3 to the x is equal to 1 9. We can make their base the same by bringing the 9 up, which will be, hold on, before we bring the 9 up there, we can simplify the 9 or rewrite 9 as 3 squared and then bring it up there. That will give us 3 to the x equals 3 to the negative 2. Cancel this out, so x equal to negative 2. Next, log of 1 with a base of 4 is equal to x. 4 to the x is equal to 1. What was the mystery number of x there that will give us 1? And that will be only 0, 4 to the 0. So therefore, x is equal to 0. I would like you to try and practice this set of problems. Pause it and try it on your own. There you go. Okay, log of 64 to the base of 2. Again, I'm going to think of think of a number that when you multiply 2 multiple times will give you 64. Or what must be the base, or what must be the exponent of 2 that will give you 64? If we look at the chart that we did a while ago, 2 to the 5th is 32. If we do 2 to the 6th there, it's 64. So the answer there is 6. So 2 to the 6 is going to be 64. So the answer here is 6. Or we can do the other way around. We can set it equal to x. 4 to the x is equal to 1 over 64. We know our goal is to make their base the same. So this 4 to the x is 64 is same thing as 4 to the third power. Then that third power will go up. That becomes now 4 to the x is equal to 4 to the negative 3. Cancel the 4, so x equal to negative 3. Next, log of 1 with a base of 5. And then again, we'll set it equal to x. 5 to the x is equal to 1. We know that 5 to the x is equal to 5 to the 0. And 5 cancel out, so therefore x equal to 0. Here, if you notice, log of negative 3 to the base 6, the logarithmic number is negative. We never have an example that is negative for the log number. There always can be a fraction of 1 or any regular positive integer. This time is negative 3. The answer here is undefined. There's no way we can get a negative number there. That's impossible. Log of 3 with a base of 9. So here, we're going to set it equal to x. 9 to the x is equal to 3. We're going to try to make their base the same by changing the 9 to 3 squared and drop the x there is equal to 3. We know that the invisible exponent of this 3 here is 1. So now they have the same base. I can cancel this. That will give us 2x equal to 1. So therefore, x equal to 1 half. Last problem here, I have here x equal to x. So I will have 1 half of x, 1 half raised to x is equal to 1 half to the 8. We know that I can bring the 2 up there. That will give me 2 to the negative x. I can change the 8 to 1 and 2/3, and the 2 to the third will go up. That will make it 2 to the negative 3. So therefore, the 2 cancel out. That will leave me negative x equals negative 3, or x equal to 3. Kaboom. And that's how you evaluate logarithmic expression.